In this video, we're going to be introducing rainbow LED strips. With these, you can do amazing things. They're used in cosplay quite a lot. They're excellent for indicators because you can do different colors with them, different patterns, and we're going to have a lot of fun getting into it. We're going to be getting our hands dirty, having a little bit more of a play with code, understanding a few more items about it. Basically, it's just about doing the practical things that you need to do to get this done. So, let's get started. So RGB strips, or red, green, blue strips, are sometimes referred to under the brand name that Adafruit uses called NeoPixels. So these are fairly common and a lot of people are getting into them, mainly because you can do so much with them without too much effort. After you know how to use them, you'll find ways to incorporate them everywhere. So here we've got a few examples. Bottom left here is Disco Dog, basically a jacket for your dog that pairs to your phone over Bluetooth. When it's lost, it even says lost dog, please return. Bottom right here is Daft Punk, the helmet. A lot of people have recreated this, but with an RGB strip, you can actually create your own patterns and your own sequences as you please. You can have that interact with a sensor, or you can just have it run through sequences. And the simplest of these examples are these outlines of frames up at the top here. They can add very nice ambient lighting. So to be able to use the RGB strips, first we're going to need to acquire them. There's a few places and I've provided the link in the notes. To be able to use them, however, we're going to need to add a library. So let's go and do that. So to be able to add libraries to the Arduino IDE, we're going to follow the link in the notes to the side, click View Raw, and then the file will be downloaded. This one I've already downloaded. Opening up the Arduino framework, import library, add library, locate it, selecting the folder itself, go choose. I've already imported mine. And then you will find a couple things are added. In the examples, we'll have NeoPixel library, simple, button, and strand. We're going to have a look at the simple file as an example on how we're going to proceed. So we're going to see a few interesting things in here, but basically what we're going to do is adjust it as we need. Before we continue, let's hook up a NeoPixel strip. So here we have an already wired up RGB strip. You can see that there's 3 wires. The red, which is connected to the Arduino's 5 volt, connects to the strip's 5 volt. This provides power. The ground, the black wire, is connected from the Arduino's ground to the ground of the strip. This provides the closing of the loop of the circuit. And then the data pin, we've gone and connected it to digital 6. So this can be changed later in the code, but you're just going to need to know that by default it's 6 and we can change it. So let's step through the code that we're going to use for these RGB strips. I'm going to explain it at a little bit more of a higher level, and there are only certain things that we need to pay attention to. There's a lot of information here, but we only need to pay attention to certain things to be able to practically use these strips. The first thing of interest is that a particular library is used. So this library gives us access to additional functions. So this stuff is fairly standard for it, and as long as we have it, we're going to be okay. The first important step, however, is defining what pin we're going to be using. And so this is what I was saying before. You can have it on any pin as long as we define it correctly here. So it's 6. If you're going to use the analogs, you need to prefix it with an A0, A1, continue like that. The next part is the number of pixels that we're going to be using. So we're defining a variable called numpixels, and we're using 16. If you have a different amount in your strip, please adjust for that. One note about the number of pixels per strip is there's limitations in terms of the number that, say, the computer over USB can power. And I'll put a link to the documentation on the notes. The next part is really interesting because this is the first time that we've come against objects. So what we can do is we can create something called an object, and that object has functions that it owns. So say that we're creating shapes. So we would have a triangle. A triangle is an instance of a shape. Shapes have sides. Shapes have area. But a triangle has a very specific relation between the sides, 3, and the area, half length times width. So here we have an instance of an object. So we've created something called pixels. So that particular strip, we're creating a little mini version or representation of it inside the software. We've said, go use this library, create an instance of the object, and it is this. And so it executes this function. This function allows you to create an instance of the object. So into it, we're going to feed the number of pixels that it is, the pin that it's connected to, and there's a little bit of data here about the protocol that we're going to use to communicate to it. We don't need to worry too much about this. All that we need to know is that each time we want to refer to that particular strip, the one that's connected to pin 6 and has 16 pixels in it, we're going to call it pixels. So if we skip down, this is one of the other parts that's important to creating the RGB strip. And this is saying that we're ready to begin. So after the setup is finished, we begin. So in the future, when you're going to want to create your own strips, use this code as a base. But the interesting part is what we're going to have a look at here. Skipping this part for 1 second, we'll come back to, but the more interesting part are these two lines here. So we're addressing the pixels, the strip of pixels, and we're invoking a particular function, set pixel color. So this set pixel color takes two parameters. One, which is which pixel do we want to talk to, and the second one is what color do we want to set it. Don't worry about the function that we're going to be running here. Only worry about these three numbers, the red, green, and blue amount of light being asked of from that pixel. These have a range from 0, as in none, all the way up to 255, which is full. So if I made this all zeros, the pixel would have no light whatsoever. If I made this 255, it would be fully red. If I put that back to 0, 255 here, this would be 100% green. And this would be blue. If I made it like this, however, it would make magenta. So here we have the RGB, red, green, blue, color wheel. So these are the three numbers that I was mentioning in the code just before. To be able to get any of these particular colors, you can look it up here. So if I wanted yellow, I would put 255 in the red slot, 255 in the green slot, and 0 in the blue slot. And that creates yellow. So let's take a practical approach and upload to the controller. Here you can see that it stepped through each LED and pushed a color to it. So now going back into the code, let's have a look at how it actually did that. We're going to introduce to you something called a for loop. The for loop gives you the ability to step through a sequence of numbers. The first part is, what is the starting number? The second part is, what is the rule for continuing? So as long as this rule is true, we will continue. And the third part is, what do we want to do to that number each time? So what we need to do is increment it. So let's say that we've got this variable I and we assign it 0. So the first time it goes through this loop, every time you see I, it's going to have the value of 0. So going in here, we see I here. So this means that it's addressing the pixel with the address 0, so the very first one. Note that, again, in computer terms, 0 is the first of many things. As we exit out here and come back into the top, we have to do this function first. So now that we've passed through once, we execute this function. This actually means increment the value I. So what is that? 0 plus 1 is 1. So let's do the test. Is 1 less than number of pixels? Yes, because number of pixels is 16. So now that when we go through it, I is 1. And where do we see I? Here. So this says put a 1 in this value. So now we're addressing pixel 1 and we push a color to it. And we keep going, we keep continuing. Adding 1, testing that it's okay, and then executing upon it. This will keep going until we get to 15. When we get to 15, the number of 15 is less than the number of pixels, but if we were to go to 16, this wouldn't work. So when we hit 16, it will stop. You also note that there's a delay. So as we're setting each color, we're also displaying it onto the strip of LEDs, but then we have a slight pause, and that's where the pause comes from. So by playing around with the colors and the delay, we can get different effects.